Okay, so we are moving on to the next skill, which is our ability to balance equations. Okay, now the basic idea behind balancing. Again, if you don't know what it means to balance an equation, you need to go back and watch the Tyler DeWitt videos I posted on the same slide this was linked to, right? Intro to balancing equations, right? And the practice problems, okay? Go back and do the work to understand what it means to balance. This video really is here just to help you see, you can hear Mr. Hudeberg think out loud as to how I went about balancing these, all right? So with balancing, again, I taught you guys in class, and this is what I recommend, right, is to write your reactants and how many there are. So on my reactant side, I have 2 aluminums, 3 seleniums, and 1 potassium on my reactant side. On my product side here, I have 1 aluminum, 1 selenium, and 2 potassium. So we are not balanced. So we need to go about balancing to make sure we have the same number of everything on each side. So we'll start with aluminum. We have 2 here. So I will start by just putting a 2 right there, which would now make the product side also a 2. So my aluminum is now balanced. I have 3 seleniums on this side, as indicated by that little guy right there. Okay, so I need to also indicate 3 seleniums on this side. So the way I do that is by putting it as a coefficient in front of whatever selenium is attached to. Cannot do that. Do not change subscripts in order to balance. We write subscripts based on charges. I know I've said that about 1 million times in the last week. I want that point driven home. All right? We balance with coefficients. Now, that gives me 3 seleniums on this side. Now, over here, I have 2 potassiums and only 1 potassium on the reactant side, so I just need to fix that by putting a 2 there. Balanced. Man, got a little bit messy there. All right. Next one. Let me get rid of some of this mess we got going on here. Sorry about that. Unprofessional video editing capabilities here, but we will get it knocked out. Okay. Now, back to business. Step B. I've got barium nitrate, magnesium hydroxide, magnesium nitrate, barium hydroxide. This is a classic double replacement reaction. All right. Now, on my reactant side, I have 1 barium. I have nitrate, 2, 1 magnesium, and 2 hydroxides. My reactant. On my product side, I have 1 magnesium, 2 nitrates, 1 barium, and 2 hydroxides. So 1 magnesium, 2 nitrates, 1 barium, 2 hydroxides, already balanced. I do not need to add any subscripts. That's kind of handy. All right, letter C. Looks like we got some manganese oxide. Carbon monoxide produces manganese and carbon dioxide. So on my reactant side, I got 1 manganese. Got 1, 2, 3 oxygens. And 1 carbon. So 2 oxygens plus 1 oxygen makes 3. On the right side, I got 1 manganese, 2 oxygens, and 1 carbon. All right. Now, what we're going to have to do here, we have a 2 there and a 3 there. Manganese is balanced. I got 2 there. So I'm going to have to increase my oxygens over on my right-hand side. Okay? So the only way I can do that is to put a coefficient that is not 1 in front of the carbon dioxide. So I'm going to put a 2 there. All right? Now, what that did to this side is that gave me 2 carbons and now 4 oxygens. And that seems like it might have made matters worse. Okay? But if I now go back over here and put a 2 here, that gives me 2 carbons, right? And 2 oxygens plus 2 more, 4 oxygens. That is now balanced. Alrighty-o. Next one, we got a nice little combustion reaction here. So on my left side, I've got 7 carbons, 16 hydrogens, and 2 oxygens the way that's written. On my product side, I've got 1 carbon, 3 oxygens, 1, 2, 3, and 2 hydrogens. Now, when we do combustion reactions, as I mentioned in class, we always start with the carbon and hydrogen first, right? If we're not able to balance the oxygen at that point, we go back and double everything. So let's see how it works just by balancing our carbon and hydrogen. So I've got 7 carbons over here. I'm going to go ahead and put a 7 there to make this a 7. Now I have balanced my carbons. I have 16 hydrogens here. I need 16 on this side, so if I put an 8 there, 8 times 2 is 16. That takes care of the hydrogens. Okay. Now, let's count up how many oxygens I have on my right-hand side. I've got 14 plus 8, which makes 22. All right. I can turn this into a 22 by putting an 11 there. And we're balanced. Okay, and last, one more. We got nickel sulfate, silver nitrate, silver sulfate, nickel nitrate on this side. All right, so let's write our reactants out. We got nickel. We got 2 of those. We got sulfate. 3 of those. And we got silver. Looks like 1 of those. And nitrate, 1 of those. On the right hand side, I got nickel 1 and sulfate 1 and silver 2, nitrate 2. So we're all kinds of unbalanced. So if I got 2 nickels here, let's start by throwing a 2 right there, right, which makes this 2. Sorry, there should be a 3 there. Excuse me, originally. 3 nitrates. But now that I added a 2 there, that makes 2 times 3, 6 nitrates. Okay? Now, let's see. We've got 3 sulfates over here, so I'm going to have a 3 here to even that out. Right? Which now makes that 6 silvers on this side. So we got 2 nickels, 3 sulfates, 2 nickels, 3 sulfates, 6 silver, 1 silver, 6 nitrate, 1 nitrate. I gotta throw a 6 right there, and that takes care of balancing.